Isn't force just the sorry, let me just get it. Isn't force the a transfer of energy in a certain?
Okay, kind of you can say, but in proper, like in simple word, if you have to define a force, you can say that pull or push basically is known as force. Or a force is something that causes a change in speed, a change in motion basically, and change in shape.
Okay.
Now you can say and size, shape and size. So definitely, like if there's a balloon and you're squeezing that balloon, so what you're doing, you're changing the shape of that object. Or if there is any like clay, if it's clay and you're just pressing that clay, what you are doing, you're just changing the shape and size of that clay by applying the force. So basically, a force is something that causes a change in motion and size and shape of an object. Okay.
Okay.
Now, if we are studying force, force basically, the first thing is force is categorized into a balanced one and unbalanced one. So balanced force and unbalanced force.
So why is it called unbalanced? Unbalanced.
Yes. The thing is that if you see a stationary object resting on table, you tell me how many forces are acting on that object.
Well, gravity. Wait, is it on a table?
Uh, yes. So on table, how many forces are acting on it? So first you are saying it's a gravitational force, and second,
Friction.
okay. So yeah, friction you can say, and then
What else? So, I don't think there's any else.
okay. So like if you think it's a friction, or like if it's if an object is moving, then we consider the friction force. Otherwise, if it's only we take the gravitational force, then it should fall under the table, right? Fall inside the table. If it's only the gravitational force, like this is table, and this one is an object resting on table, and it's only the gravitational force. So gravitational pull is what? Downwards. So it's
Yep.
something that is pulling you downwards. You have to fall inside that, right? Why still that object is resting on table? Why it's not falling under that gravity?
Wait, pardon?
If it's only gravitational force that is acting on this object, then why it's still stable? Like you can see that something is pulling that object downwards. This is resting on table, not moving at all. Why it's so happening?
I know what you mean. There's a counteracting force, but I don't know what is it called.
Yes. So definitely, if it's in a state of rest, that means that if the forces are acting on that, so another force in opposite direction of equal magnitude should be there. That's why it's resting on table, and that is known as reaction force. So reaction force is the force exerted by the table on the object. Okay.
Okay.
So it's a gravitational pull, and whereas in opposite direction it's the force exerted by the table on the object, and they are equal and in opposite direction, and that's why these forces are known as balanced forces.
So there's nothing. There's no movement or anything.
Yes, that means suppose if an object is moving with constant velocity 2 meters per second, so it will continue to move with same velocity if the forces are balanced on it. So an
Okay.
object remains in the same state of motion if the forces are balanced. If the forces are unbalanced, that means there is no counter force. Take the example, now if I give a push to this object, so definitely for my force there is no counter force. Definitely it should be friction, but to some extent. After that, the friction value, the force of friction will also reduce. Okay, like if you start applying the higher force, say for example you are applying 2 Newton of force, and the friction is also of 2 Newton, then you won't be able to move that object. But if you increase your force, say from 2 to 20, now you have overcome that frictional force. So this force now is known as your unbalanced force, because there is no force which is balancing, which is in opposite direction or of equal magnitude. Is this point clear?
Yes.
So this kind of force is known as unbalanced force. That means you can clearly see that if the forces are balanced, then object remains in a state of rest or in motion. Like it will continue to be in its initial state. If it's in rest, it will continue to be in rest. If it's in motion, it will continue to be in the same motion, like with the same velocity. But it's the unbalanced force which causes a change in motion of an object. If there's an object which is resting, and if I give a push, and there's no counter force for that, that is my unbalanced force, so that object starts to move. Or if there's there's a ball and I kick that ball, what happens? It starts to roll. So it's the unbalanced force which is responsible for changing the motion of an object, and that is concerned with the first law of motion. So according to the first law of motion, an object remains in a position of rest or in motion until unless exerted by an external force or unbalanced force. Unbalanced force has another name, that is known as external force. Is this clear?
Okay.
What's the first law?
Could we skip most of this because I already know most of it.
Okay, so you know that. So you know what's
Yeah.
a second law of motion?
The second law of motion. Oh God. I know the first and the third. The second, wasn't it?
Basically, there are three laws. So what is the second law then?
Wait, so Newton's second law of motion says that no, I don't know. I know it, but I don't know how to describe it.
Okay, so we can say according to the second law, force is directly proportional to the acceleration. If you keep on increasing force, the acceleration of body keeps on increasing. And by this, you get an equation F equals ma, m is constant there. And this is the formula of calculating the force. So that's the second law. So force is directly proportional to the acceleration of a body. So if you keep on increasing the force, the acceleration keeps on increasing. That's the second law. Is this clear?
Yeah.
Okay. Now, there's a question I'm giving you. There's also, do you know what's momentum?
Momentum.
Yes.
Yeah.
So what's like formula? What's the formula?
With the formula for momentum.
Yes.
So isn't it momentum equals mass times velocity?
Yes, that's correct. Momentum is mass times velocity. So according to the second law, generally, second law is force is directly proportional to the acceleration, but it has a different, another statement also, which states that force is actually, it's a real statement, force is directly proportional to change in momentum, rate of change in momentum. Is this clear?
Yeah.
So it's rate of change of momentum. So change of momentum over time. Okay. So change of momentum, which means your final momentum minus initial momentum. Is this clear? What is change in something? Like if
The change, the difference between it being something before and present, what it
yes,
is.
yes, that is final minus initial, you can say. The final value minus the initial value. So
Yeah.
so change in momentum, you can say final momentum mv final minus mv initial over time.
Wait. So what is this formula for?
This is momentum. mv is momentum, and this is force that I'm saying. Force is this is another statement. The first statement for second law is force is directly proportional to acceleration, which means if force increases, acceleration increases. They share a direct relationship. And another statement for the second law is force is directly proportional to change in momentum over time, or force is directly proportional to rate of change of momentum. Is this clear?
Wait, could you repeat that?
So its force is directly proportional to rate of change of momentum.
Right, so momentum is directly proportional to the change of what?
Force is not momentum. Force is directly proportional because we are studying laws of motion. So it's the forces that we are concerned. So force is directly proportional to rate of change of momentum.
Okay.
So that I'm writing here, it's rate of change of momentum, which means change in momentum divided by time. Anything, rate of change of something, like, so rate which means divided by time, you're talking about per unit time. So rate of change of momentum, which means change in momentum divided by time, that I've written here. Now
Wait, what?
change,
So
yes, yes,
I'm getting a little confused. So the change in momentum divided by time equals what?
force,
Force.
yes. Okay, wait a second. I need to log out, actually. It's what I can say. When I write, it's breaking. So just hold for a second. I'm just logging out and relog it, okay?
Okay.
Hello.
Hello?
Yes. So I was explaining you the second law.
Uh, so you were explaining force equals momentum divided by time.
Yes. So you can write either the force as mass times acceleration, that you can write, or there's another way of
Yeah.
writing. You can write force is proportional to change in momentum, change in momentum over time.
Okay.
So change in momentum, which means final momentum minus initial momentum. So I'm writing change in momentum, which means final momentum minus initial momentum divided by
Okay.
time. This is F. Is this clear?
Wait, so force equals what? The PT minus
PF.
the.
P is actually momentum. Like the notation for writing momentum is P. And F is for final, I is for initial. PF, which means final momentum, and PI is initial momentum.
So it just means change in momentum divided by time.
Yes. Okay. So in place of final momentum, I can write mass times final velocity. And for initial momentum, we can write mass times initial velocity. Clear?
Yeah.
Divided by time.
Clear.
If I take out mass as common, because mass remains the same. If my velocity is changing, my mass remains same definitely. So it's mass that remains same. Now you can write final velocity minus initial velocity over time. You tell me, what do you mean by final velocity minus initial velocity over time?
So wait, could you repeat?
Yes.
So mass times final velocity divided by time.
Yes, so only this one, leave that mass. Only final velocity minus initial velocity over time is what?
So mass times final velocity divided by initial velocity, isn't that divided by time? Isn't that 1?
No. Only this part I'm
No.
talking about. Only this part. Leave that mass there. Only this
Oh,
part. What is VF minus
yeah.
like final velocity minus initial velocity over time is what? There's another word for it also.
Isn't wait? So are you trying to make me say another way of saying the formula?
Yes, like there is another word also. That means if I
Oh.
say yes.
So is it changing velocity?
Yes, it's change in velocity over time is what?
Over time equals mass.
Change in velocity over time is what?
Wait, what does momentum?
Momentum is change. Momentum is mass times velocity.
Wait, what does the M stand for?
This is mass.
Okay, so isn't so the VF minus VI equals the change in
Sorry.
velocity over time. Is it equal to mass? Because now I'm a little confused.
Okay. Wait a second. First, step by step. You tell me, force is according to the second law. It is the law that is stating this, that force is directly proportional to change in momentum over time. Is this one clear?
Okay.
Then next, another way of writing change in momentum is what? Final momentum minus initial momentum over time. Is this point clear?
Yeah.
Then what I have done, I just put the formula of momentum. Here I was just writing change in momentum, but now it's a mathematical term that I'm using. Before that it was just a physical one that I was using, but now I moved on to mathematics. So that's why it's mass velocity minus mass velocity, like mass times final velocity minus mass times initial velocity divided by time. Okay. Now clearly you can see mass remains same. That's why I have taken mass as common out. And inside the bracket, it's V final minus V initial over time. So I'm talking whatever inside this bracket. Is there any another way that I can write this one? Only just don't see the mass. Only whatever it's inside the bracket. Does it seems to be similar to you? Like familiar to you? That's change in velocity over time is something that you have read before.
Okay, I'm getting really confused now.
Okay, you tell me. Where is the confusion?
Because okay, so I understand the changing the change. So force equals change in velocity. I mean momentum divided by time.
Yes.
And then it can be rephrased as force equals uh, the the final momentum versus the initial momentum divided by time.
Yes.
And then so divided the MV minus MVI divided by time.
Yes.
I mean MVF.
Yes.
So What is that equal to?
That is equals to force that we are writing, right? It's constantly equals to force. Okay.
Okay.
Actually, P final is equals to M times V final. And P initial is equals to M times V initial. Is this clear? Because momentum is mass times velocity. That's why. Clear?
Clear.
And then I can take out mass as common, and it's only V final minus V initial over time. And change in velocity over time is basically acceleration.
So change of velocity over time is acceleration.
Yes. So here I can write acceleration. So force is equals to mass times acceleration.
Oh, okay, I understand now.
Is this clear? So this is
Yeah.
actually the derivation, how you get force is equals to mass times acceleration. And that's why Newton's second law can be stated as that force is directly proportional to rate of change of momentum, or force is directly proportional to the acceleration. Is this clear?
Clear.
Okay. So now let me do some questions.
The questions.
Yes, on second law, so that it should be much clearer to you.
Okay.
So let's give it as, wait a second. So the first question is given as skydiver. The skydiver jump from a plane. Each holds a different position in air. I think I should upload this. It's better. Okay. Before I upload, I'm just giving you one question to solve. So it's given as that a car is moving with a velocity of 20 meters per second. After
Okay.
100 seconds, its velocity changed to 120 meters per second. If the driving force is equals to 120 newtons, calculate the mass of the object. Okay, I'm just repeating the question. An object is moving with a velocity of 20 meters per second, and after 100 seconds of time, it's in seconds, after 100 seconds, its velocity changes to 120 meters per second. If the driving force is of 120 newtons, then you have to calculate the mass of that object.
Okay, so the force equals 120 newtons, and okay, so the time is 100 seconds. Wait, so are you asking me to find what?
Mass of the object.
Mass, okay. So the acceleration equals the change in v over t. So the change it is 100 meters per second. So the acceleration is, wait, what is acceleration measured in?
It's meters per second squared.
Okay, so 1 meter per second squared times. Okay, so force equals 100. So mass equals 120.
Yes.
Hello?
Yes, yes.
No, I just said that the mass is the mass is 120 kilograms.
Okay, yes, that's correct. Okay, now I'm uploading a PDF. Okay, it's taking time. So till then, this is force. You tell me what's the third law of force, and also like you have already know the first law of force. So can you just explain me the term inertia?
Pardon?
Inertia. It's
Uh,
something that you should know if you know the first law of motion.
uh, but isn't inertia Newton's third law?
No, inertia is from first law.
Oh, first law.
Yes.
First law. Okay, so Newton's first law is that an object is going is has a balance force unless a secondary force is acted upon it.
Yes, unless an external force or unbalanced force acts on it, so it will continue to move with the same velocity or with same state, you can say. And inertia is something that is the property. Inertia is like it's the outcome of the first law. So, and if we see the definition of inertia, so it's the property of an object that resists the change in motion. That's inertia. Okay, which means like if there's a ball and if you kick that ball, so just for fractions of second, it will not move. Why? Because it will try to resist that motion. So that resistance of motion by an object is known as inertia. Okay, that means
Okay.
that's the property of an object. Like if no external force, it will continue to move with the same velocity. Why? Because it's resisting the change, and that is known as inertia. So it's very much important term. Like if in higher classes, it's the Newtonian physics that deals with inertial and non-inertial frames. So inertia is very important thing that is deduced from the first law. So in short, if you have to define a property like its definition, so you can say the property of an object that resists a change in motion. Simple. Okay, so at first if you try to change the motion of an object, it will resist at first. Okay, and like one of the most common example you can say is like if you're sitting on a moving bus and suddenly it stops, you move in forward direction. Why? Because bus is moving, your body is moving. But what happens when suddenly your bus stops, your body remains in a state of motion. So your body was like in motion even the bus stops, and that's why it moves forward, because it was moving, your body was moving. Bus stops but your body still moves, and that's why you move forward. Is this clear?
Yeah.
And same as this is known as inertia of motion. Inertia of rest is something like if you're sitting in a car which is a stationary and suddenly if it starts, so your body is in rest of like it's in position of rest, and suddenly car starts to move but your body remains in rest, so that's why you move backwards. So like moving forward or backward is something that is related with inertia. So like sometime it's been asked to define inertia, that's why I was explaining it. Okay, so is this inertia clear? How can you define inertia?
Okay, so inertia is basically when an object will just stay motionless unless a secondary force is acted upon it, such as it's, such as somebody moving it.
So in short you can say, like if you have to define inertia, it's a very simple and single line definition. You can say a property of object that resists a change in motion. It's a property of an object that resists a change in motion. Can you define that? Like,
Could you repeat?
it's a property of an object.
Wait, what do you mean a property of an object?
Property, which means like a human has a characteristic, like someone is short tempered, someone is very calm. It's the characteristic of a person, same as the objects has their own property. Like some objects are shiny in look, some objects are very dull in color and rough in surface, their property. So same as inertia is also one of the property of an object. Is this clear? What do you mean by property? Their characteristics. Okay.
Okay, so what do you mean by the properties of
Object.
yeah, so what do you mean by that?
Like property of an object, which means it exhibits that. Every object shows that characteristic, shows you that particular thing. That is their property. Okay.
No, I'm confused by what do you mean because
Okay. So let me clear you.
okay, so do you want me to describe the properties of inertia or what?
No. I'm just giving you the definition of inertia. Inertia has a simple definition, which means it's a property of an object which resists a change in motion. That's the definition of inertia. Is this clear or is there any confusion?
Okay, so inertia. Okay, I'm lost now.
Okay. See, suppose I want to run in a race, okay?
Yeah.
And I'm so much desperate about it, but somebody come to me and say that you should not participate in. So what basically he's doing, he's resisting me, right? He's just stopping me to participate in that race. But
Wait, what?
this is hello.
I can't hear you properly, really.
Okay, is my voice clear?
No.
Okay, wait a second. Hold on a second. Hello.
Hello?
Yes, can you hear me properly now?
Yeah.
Okay. So basically, suppose I'm desperate to do something. I'm participating in a race and I really want to participate in that race, but somebody asked me not to participate. But I'll say that no, I want to participate. So what I'm doing, I'm just resisting what he's saying. He don't want me to participate, but still I'm resisting to participate. So
Yeah.
that's my characteristic, that I'm stubborn. I'm not listening to anybody. That's my characteristic. The same thing is the property of an object. If you try to move that object, at first it will not move. It will resist to change. Like if I kick that ball just for a fraction of second, it will not move. After that it will move. That means at first fraction of second it resisted my motion. It resisted my kick. So that property of an object is known as inertia. Is this clear?
Okay. So you're saying the prof. So are you describing the property of inertia or the property of an object?
Inertia is a property of an object.
Okay.
Is this clear? Like I was resisting, I was denying
Yeah.
that person that I don't like I will participate, so I'm stubborn. So stubborn is my characteristic. Okay, same as inertia
Yeah.
is characteristic or property of an object. Okay, of any object. Clear?
Clear.
It can be any object, living or non-living. It can be any object. So like generally in some place inertia is being asked. That's why I was explaining you. So if you have to define it, you can clearly say inertia is a property of an object that resists the motion. That's clear. Now see this one. There are some questions. These are the questions related to the second law. Okay.
Okay. Wait. So look at the. So wait. What? Do you want me to answer them?
Yes. Question first. Answer this one.
Okay. So the first one. Skydiver B will fall faster because there's less surface area. There's less surface area the wind is hit. Wait. Yeah. Yes. So Skydiver B will fall faster because there is less surface area the air is hitting, so he can't get as much lift.
Okay. So complete the following sentence. Skydiver Ash will fall faster because okay. Now the second one. The diagram shows the direction of forces acting on one of the skydiver. In the following sentences, cross out in each boxes two lines that are wrong. Force X is caused by. That is this downward force X is caused by which out of these three?
Gravity.
Yes. And the next one. Force Y is caused by that upward force.
Force Y is caused by so air resistance.
Yes, that's correct. Now, when force X is bigger than the force Y, the speed of skydiver will. That means the downward force, if becomes bigger than the upward force, what will happen to the speed of the diver?
Just wait a minute, please.
Okay.
Okay. Hello.
Yes.
So force Y is caused by air resistance,
Yes.
and so when force X is bigger than force Y, the speed of the skydiver will go down. After the parachute opens, force X goes. Force X stays the same.
Okay. So for this, what's the answer? Goes down. That you're saying.
So when force X is bigger than force Y, the speed of the skydiver will So when force X is bigger than force Y, the speed of the skydiver will go up.
Yes, that's correct.
So part 4 of it, after the parachute opens, force X stays the same.
Okay. So after parachute opens, you say the force X remains the same.
Yeah,
And why?
because doesn't force Y increase?
Yes, that's correct. So it stays the same. Right. Okay.
How does that?
Yes, yes.
Oh no, I was answering part C.
Okay. Like I thought you were answering part 4 that it stays
No,
the same.
yeah. So yeah, it stays the same.
Yes, yes. And now part C. So what? So you say that the force Y becomes bigger, right?
Yeah. So so force Y becomes bigger because of that. So because the area of the open parachute affects the size of force Y because there is more air particles hitting the parachute, so that's increasing the air resistance.
Yes, that's correct. So drag basically increases.
The diagram shows a skydiver in a free fall. Two forces X and Y act on the skydiver. Complete these sentences by crossing out one. Okay, so force X is caused by force X is
Like 2 lines are correct, you have to take the wrong one.
yeah, I understand, but okay, force X is caused by weight.
Actually, it's caused by weight and gravity, but you have to mark that one is wrong. So it's friction, which is wrong.
Oh, okay, so force Y is caused by is not well. The one that is wrong is air resistance. I mean friction.
It's gravity. Basically, the air resistance is air friction. Okay, so it's another word.
So friction is also
Yes, like uh, if it's between the solid and solid, we call it friction. And if the friction of air molecules, we named it resistance or air resistance, but it's the friction of the molecules, okay, of air molecules. Is this clear?
yeah. Can I just note some things down, please?
Okay.
Okay.
Okay, now for part B.
Part B. The size of force X changes as the skydiver falls. Describe the motion of the skydiver. Force X is smaller than force Y. The diver falls downwards because there's less air resistance. There's more gravity potential energy than air resistance.
Yes.
Okay. Force X is equal to force Y. So then, in this one, so the skydiver was still stay in the same place.
Yes, which means it continue to move with a constant velocity or constant speed, or this vessel is also known as terminal velocity. So in short, you have to say it will continue to move with constant velocity. Okay?
Yeah, constant velocity or is motionless.
Yes. And for this one,
Uh, so the shopping trolley is pushed at constant speed. That represents the horizontal forces on the trolley. How big is force B compared to force F? Uh, force P is greater.
it's of same size.
Oh, wait,
Because
no.
it's moving with
Oh,
constant velocity, right? It's written constant velocity.
okay.
So according to the first law, a body will continue to move with the same velocity if no external force. That means forces are balanced. That's why P is equals to F. Okay?
Okay.
Okay, now the next part. Which one of the distance time graph KL or M shows the motion of the trolley? Which one shows the motion of the trolley?
So So which one of the distant time graphs can alone show the motion of the trolley? Wait, so distance. So the first one, K.
Yes, that's correct, because it's moving with constant velocity. Okay, now complete this sentence by crossing out the two words in the box that are wrong. Acceleration is the rate of change of what?
So complete the sentence. So acceleration is the rate of velocity.
Yes, it's a rate of change of velocity. That's correct.
Okay, so.
And also, three trolleys A, B, C push using the same size of force. The force causes each trolley to accelerate. Which trolley will have the smallest acceleration? Give a reason for your answer.
Trolley C will have the smallest acceleration because it has the most mass.
Yes, because it's the heaviest one. And here you just have to match the column.
So draw only 3 lines. So the first A is stationary.
It's constant speed, you can see, because it has it's a driving force also, and it's backward. It's moving. It's already moving. Okay.
But wouldn't it also be stationary because it could just be still and have two forces acting on it?
Yes, definitely two forces are acting on it, but it's given as draw a line each diagram to describe the car's motion at the moment when forces act. Okay,
Yeah,
so it's given as acting on a moving car. It's written.
Oh.
Okay, so it's already moving, and suddenly the two different equal and opposite forces are acting on that. So what happens? It will continue to move with the same velocity, right?
Okay.
Okay, now for this one.
So B would be accelerating forwards.
Yes. B and C.
And C would just be slowing down.
Yes, that's correct. Now look at for the part B. It's the front crumple zone of a car tested at a road traffic laboratory. This is done by using a remote control device to drive the car into a strong barrier. Electronic sensors are attached to a dummy car inside the car. Draw an arrow to show the direction of the car that car exerts on the barrier. Simple, you just have to draw the direction of the force that car is exerting.
Oh, okay. Oh, the direction of box 2.
Yeah, so it should be in this direction, right?
Yeah.
Okay. Now the next one.
So draw an arrow in box 2 to show the direction of the force that at the barrier. Okay, so wait, so draw an arrow in box 2 to show the direction of the force. Oh, so it's the opposite way, so
yes,
leftwards.
Yes, that's very correct. Okay, now complete this part and this part. So complete the following drawing a ring around the correct line in a box. The car exerts 5000 Newton on the barrier. The barrier does not move. The force exerted by a barrier on the car will more than, equal, or
Be
less than?
equal.
Yes, that's correct. And this one for fourth part?
Which one of the following gives the most likely reason for attaching electronics sensors to the dummy?
So
to measure the force exerted on the dummy during the impact.
So which one you're saying? It's before the impact or during the impact? That part B.
So to measure the force exerted.
Yes. To measure the force exerted on the dummy during the impact. That you're saying part B. That you're saying, right?
Yeah.
Yes, that's correct. Okay. Now it's about the forces. Now let me do some introduction of work done. Okay. So what do you mean by work done?
Pardon? So, wait,
Work.
could you say that again?
What do you mean by work done?
So, I know what the formula for work done is. It's so work done equals force times no, force times time.
Force times is
I mean,
impulse.
what?
Like FT, if you say it's an impulse.
No. So isn't work done the formula for work done force multiplied by time?
If you're saying force multiplied by time, actually it's impulse. FT, it's impulse. It's a whole different thing that you're saying. That's not work done. Work done is force times distance.
Oh,
Or you can say force times displacement more specifically.
okay. So
That means if you are applying a force and a body displays, then it's known as work done. Say for example, there is a heavy block of metal, and if you are trying to move that block and you are not able to move that block, doesn't matter how much force you have exerted, you are not able to displace that object even by a centimeter. That means no work done. It's a zero work done. No matter you have consumed your whole energy in moving that object, but you haven't displaced that object even by a single centimeter or by a single millimeter, then it is considered to be a zero work done, because it's force times displacement. So work done in physics, like in general you say I have done so many work, but in physics of work done is what? When you're applying a force and you are able to displace an object to some distance, then this is known as work done. Clear?
clear. Okay.
So you can say when a force causes a body to move, that is known as work done in simple sentence.
Okay. Let me just jot a few things down.
Okay.
Okay. So
Yes. So it's work done.
uh
Yes.
yeah.
So that's basically work done. Now work done is measured in what? What's the unit?
Newtons? No, joules.
It's joules. Now there's also another thing that is measured in joules. You tell me what is that?
Well, another thing measured in joules. Uh, isn't. No, I'm not sure.
It's energy.
Wait, what is the formula for energy?
Energy has no formula. Like energy has different energy is different formula. Like kinetic energy, so it has formula half mv square. It's potential energy,
Oh,
gravitational potentials if mgh, or if
oh,
it's like
energy as a whole.
Yes, it has different form. Like it has a statement, it's a law of conservation of energy, that energy can neither be created nor be destroyed. It can only change its form from one form to another form. So it depends on the
Yeah.
form of that energy. So basically, why work done and energy has same unit? Because energy keeps on flowing, right? Because it keeps on changing its form, that means it's flowing. So when energy is transferred through something, that is known as work done. That means, suppose this is an object and you're pushing that object. So what basically you're doing, you're applying force, or in other words, you're applying force and make it to move through some distance. So you are exerting some energy, you're transferring some energy. If you're transferring energy, then it's possible for that object to move. Okay, for anything, if it's anything is moving or like anything is happening, it's basically due to the transfer of energy. Like take the example of light, why it's glowing? Because of transfer of energy. That because of electrical energy, when you turn on the switch, an electric circuit completes, and it's basically an electrical energy is converted into light energy. Or if you can see light coming from sun, so it's a nuclear energy converted into thermal energy or the light energy. So in everywhere, if you see, it's basically the energies conversion. If you turn on your mobile, so it's a chemical energy of a battery is converting into the light energy, that you are able to see that mobile. So everywhere, everything is what the energy, it's because of energy, it's because of flow of energy. So same thing is, if you are pushing an object, so you are transferring your energy to that object, and that's why by taking that energy, object is able to displace itself. So energy is transferring by which mode? By work done. And that's why how much energy you have, you are consuming that amount of energy in doing the work, and that's why they both have the same unit. So you can say work done is what? Energy transferred. Work done is equals to energy transferred, not
Okay.
energy but energy transferred. Difference. You can't say work done is energy purely, it's energy transferred, which means when one form of energy is changing into another form, via which, that is work done. Is this clear?
Oh, yeah.
And that's why they both have the same unit.
Okay.
Now work done can be positive, can be negative, depending on the displacement. Like for example, these two should be parallel. This is object, if you have applied a force in this direction, an object also displaces itself in this direction. Clearly you can see both
Uh,
directions are parallel. Yes?
Sorry to bother you, but I think it's already time.
Okay. Hello? Actually your voice is breaking. So can you just repeat?
No, I think it's already time to finish this
Okay,
section
so you're, yeah,
because
yes,
it's
yes, 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 I understand.